All right, so we are going to move on to this graph. We want to find a polynomial of least possible degree that has the graph shown. So let me zoom in on this thing. And we are going to look and see what we can figure out from the graph. So first of all, notice that both of his arms are going upwards, which means this must be an x to the even. Okay, so we know it's an x to the even because of the end behavior. The next thing that we've got to figure out is it an x squared? Is it an x to the fourth? Is it an x to the sixth? What kind of x to the even is it? Okay, and remember we want the least possible degree. So we could make this x to the 1 million, but we really don't want to do that. Okay, so what else do I notice? I see it's not a parabola, so that's going to knock x squared out right off. I do see that there are two x-intercepts, and they both have this kind of cubic movement to them. So I could say that the one on the left has a factor of x plus 3, and then I'm going to cube it. Why am I cubing it? Because it has this cubic shape to it. So again, let me highlight. Instead of just drawing straight through, or instead of going, hang on, let me show you the options. Erase. Wow, erase. Okay, instead of going straight through like a line, it would be an x plus 3 to the first. It doesn't do that. So what about if it was a squared? If it was a squared, it would come down like this and then bounce back up, and it doesn't do that. So what's my next option? My next option is it comes down and has that little hiccup like a cubic does. So does this one. So that's why I'm going to a third degree. So when I look at this now, my other one crosses at positive 3, which means my factor is x minus 3. And so far, that seems to hit all the criteria. So this becomes an x to the even. Okay, so I've got x plus 3 to the third, x minus 3 to the third, so that gives me a degree of 6. And then I just need to figure out how it drops all the way down to the bottom. So knowing all of that, I am going to erase some of this stuff. Goodness, sorry, it's messy. All right, so what I have then is this. Okay, so coming back here, I've got y equals a times x plus 3 to the third times x minus 3 to the third. So if I shove in a value of 0 for x and a negative 729 for y, then I'll be able to find out what the coefficient is. And then 0 minus 3 to the third. So I get a negative 729 is a. 3 to the third is 27. And negative 3 to the third is negative 27. And so 27 times 27 is something large, which gives, 729. So I have a negative 729 equals a times negative 729. So if I divide both sides by negative 729, I find out that a is, hang on, right there, that's the one I wanted. A is 1, and we never write a coefficient of 1. So this is our final answer, and you do not need to write the 1. So that's what that graph looks like, and that is his equation. So looking at the last couple examples, find a polynomial of least degree. Sensing a pattern here. And so what are we going to do? What we have then is this arm goes down. This arm goes down. So this must be an x to the even. And it must be split. Not split. What? It must be negative. Okay, so it's an x to the even and it's negative. And so now I got to figure out what it can be. Can it be an x squared? No, because it's not a perfect parabola. Can it be an x to the fourth? Maybe. Can it be an x to the sixth? Maybe. Let's go see. So what do I have? I have y equals a. And then I'm going to have two x-intercepts. There's one here, so he's an x plus 3. And there's one here, so he's an x minus 3. So we want to talk about the multiplicity. Notice when it comes up there, this one has behavior at the intercept of a parabola. So he's going to be squared. Notice when I come up this way, this one has behavior at the intercept of a parabola. So he's going to be squared. So now let's back up the truck. If I'm assuming that this thing is a negative, because its arms are pointing down, x to the fourth, is that what I have right now? Well, my two purple numbers on this side of the screen make that an x to the fourth. So far I'm on the right track. When I generate my a, it's going to flip it by itself. So I'm just going to go ahead and concentrate on this right here. And then what I have then is y equals, which is a negative 80. Good heavens, hang on. I got distracted. That never happens. Negative 81 is my y-intercept, and that's going to equal a times 0 plus 3 squared, and then 0 minus 3 squared. So I get a negative 81 equals a. Well, 3 squared is 9, and negative 3 squared is 9. So I've got a negative 81 equals 81a. So a must be negative 1. So we're going to delete, what just happened? We're going to delete that, and we're going to make that a negative 1. Right. We're going to make that a negative 1. So this is your final answer. So again, is it flipped? Absolutely, because I just figured out that my coefficient is negative 1. And then my first factor is x plus 3, and he's squared because of the parabola shape. And x minus 3 is squared because of his parabola shape. So for these last few, which is a group of them, what we are going to do is match. Okay? So we are going to match these, and we also need to look, if I remember right, which graphs are not those, I'm looking at the very last question, which graphs are not the graph of a function whose range is. Okay, so we're going to talk about that in a second, but for right now, I would like to know which graph is x to the third, which graph is x to the fourth, which graph is a negative x to the third. So when I look at these options here, come down this way, here I go, okay, squidge, not that much. This is hard. Okay, so when oh my goodness, what just happened? Okay, go back here. I don't know what I just did. Okay, you're like, hurry up, lady. Okay, so what we have is, let's just make this one. So there's my full screen strip. My first question down here says, which graphs is that of x to the third? Blah, blah, blah. So what I want to find is a graph that goes down to the left and up to the right. Okay, so that's not the first graph because both of his arms go up. That's not the second graph because it's up to the left, down to the right. I want this graph because it's down to the left, up to the right. Okay, this one is up to the left, down to the right, but it's got a whole lot of crap going on, and it's not negative. So this graph right here goes in this spot. So now I would like to know the next one. Which one is x to the fourth? So if it's next to the even, its arms must point in the same direction. So this is the only one whose arms both go up. So he must be my x to the fourth. So my green one is going to be x to the fourth. So this bottom one down here is going to say a negative x to the third. Okay, negative x to the third. So this one is flipped. So it's up to the left, down to the right. But remember, so is this one. Up to the left, down to the right. So if we look at this one, this has 1, 2, 3, and then this intercept is 4, 5. Because it bounces off like a parabola, so it's there twice. So this must be a negative x to the fifth. So this is our negative x to the third. So he's going to go here. Which graph cannot be that of a cubic polynomial function? In other words, what's not a cubic? Which ones are not x cubed? So he's not x cubed. Okay, the purple one is. The red one, or the yellow one is, and then this one is an x to the fifth. So those are the two that are not cubic polynomial functions. And then the last question says, which one has a range that's not all real numbers? Which one has a range that's not all real numbers? So coming back here and doing a screenshot one more time. what we have is this one bottoms out right here. And he'll go up and he'll go up, but he'll never, ever, ever get lower than that lower little dip right there in quadrant 4. So he's the only one with a range that doesn't go forever down and forever up. Forever down, forever up. Forever up, forever down. Okay? So that is that section.